Section 5.6 is on inequalities in two triangles, and we have the Hinge Theorem. It says that if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second. Sometimes this is also called an Sas inequality, because what you're looking at are two congruent sides of triangles and the included angle. So you would have a side, an angle, and a side, an angle, and a side. But this is not like the Sas we did in the last chapter. This would be an inequality. This says that if AC is congruent to DF and AB is congruent to DE, and if the measure of angle D is greater than the measure of angle A, then that means that EF, which is the side opposite angle D, is going to be greater than side BC, which is the side opposite angle A. Very similar to the last section, the longer side is going to be opposite the larger angle, but now we're doing this when we're comparing two different triangles. So let's take a look at a couple examples here. So compare the given measures. So compare AD and BD. In other words, which one's longer, which one's shorter? Well, I noticed that AD is opposite the 70-degree angle, and DB is opposite the 68-degree angle. Okay. Oh, I forgot to note that there was actually a side that was congruent to itself. So we have our side, and then the included angles. So that means that, let me go ahead and write that down. DC is congruent to DC. So the Hinge theorem does apply here. And since 70 is greater than 68, the measure of this angle is 70, the measure of this angle is 68, then the side opposite the 70-degree angle is going to be greater than the side opposite the 68-degree angle. So this is what we're looking for, an inequality written like this. Compare the two given measures, so the length of AD is greater than the length of BD, because AD is opposite a 70-degree angle and BD is opposite a 68-degree angle. Now we need to compare the measures of these two angles. I'm going to go ahead and mark them here to make it a little bit easier. Angle ABD, so we're looking at this angle here, and angle BDC, which is this angle here. And we know that they're not congruent to each other. We do know that segment BD is congruent to itself, and maybe I'll go to a different color here. Angle ABD is opposite a side that's 5.5 units long, and angle BDC is opposite a side that's 5 units long. So that means that the measure of angle ABD, because it's opposite 5.5, is going to be greater than the measure of angle BDC, because that is opposite a side that's 5. So that's the kind of inequality they're looking for, something that's written like this. Which angle is greater than the other angle? This problem says find the range of possible values for x. So we're given two triangles here, and we know they share this side, so we do have our Hinge theorem in effect here, because I have two sides that are congruent to each other and then two angles in between them. Okay, and 2x plus 7, or I'm sorry, 2x minus 7 is opposite a side that's 4 units long, and the 41-degree angle is opposite a side that is 5 units long. So that means that 2x minus 7, because it's opposite a 4-unit side, has to be less than 41 degrees, because that's opposite a side that's 5 units long. So let's go ahead and solve that. So 2x is less than 48, so x is less than 24. Now let's stop and think about that. Can x actually be any number that's less than 24. Well, suppose x was 0. Let's try putting 0 in here. 2 times 0 is 0 minus 7 would give me a negative 7 degrees for this angle. An angle in a triangle cannot have a negative measure, negative angle measure. So what I need to say is 2x minus 7 has to be greater, or actually the measure of that angle has to be between 0 and 180, because the measure of any angle is between 0 and 180. So let's solve that. If you remember how to solve an inequality that looks like this. So 7 is less than 2x, which is less than 187. And then dividing everything by 2. So 3.5 is less than x, which is less than 93.5. So I have one inequality that basically says this angle has to be smaller than the other angle, and solving that for x, I got x is less than 24. But then realizing that 2x minus 7 is the measure of an angle, and the measure of an angle has to be between 0 and 180, I have this inequality here. So, like I did in the last section, I need to graph these on a number line and see where they overlap. So I have 3.5 and 24 and 93.5. So x has to be less than 24. Oh, it's a bad line. And x has to be between 3.5 and 93.5. So the region where these overlap is in here. So x can be any number that's between 3.5 and 24. X cannot be any number that's less than 3.5. Well, let's look at that. If x is equal to 3.5 or less than 3.5, then the measure of this angle is going to be 0 or less. And it can't be any greater than 24. And let's take a look at this example here. Here we have a triangle, again, that shares a side. So we have our Sas inequality going on here. And the 27-degree angle is opposite the side that's labeled 3x plus 5. 37-degree angle is opposite the side that's labeled 2x plus 3. Well, let's go this way. Since 27 is less than 37, 3x minus 5 has to be less than 2x plus 3. The side that's opposite the 27-degree angle has to be less than the side that's opposite the 37-degree angle. So solving that, I get x is less than 8. So there's one of my inequalities. But now I also have to consider the fact that 3x minus 5 and 2x plus 3 refer to the lengths of the sides of a triangle. And each of those has to be greater than 0. I can't have a triangle that has a side length of 0 or a side length less than 0. So I need to write the inequalities. 3x minus 5 has to be greater than 0, and 2x plus 3 has to be greater than 0. The sides of a triangle have to be a positive number. They have to be greater than 0. So 3x has to be greater than 5, or x has to be greater than 5/3. 2x has to be greater than negative 3, or x has to be greater than negative 3/2. Let's go ahead and graph all three of those and find the range of the values for x. Negative 3/2, 5/3, and 8. X has to be less than 8, greater than 5/3, and greater than negative 3/2. And the region where those overlap is between here. So x has to be some number between 5/3 and 8. And just to review those last points, in this case, my algebraic expression, or my x, appeared in the length of a side. And recall that the length of a side of a triangle can't be 0 or negative. The length of a side of a triangle has to be greater than 0. That's different from the previous example, where my x was in the angle of a triangle. And the angle of a triangle has to be between 0 and 180.